Welcome to Geometry Virtual Learning. In today's presentation, I'll be talking to you about volume of prisms. I will help you identify special features of prisms that will help us also work out the volume of prisms. Then we'll just go through an exam style question. These are examples of prisms, and one may ask, why do we call them prisms? Let's explain it this way. Look at this triangle. It's a 2D. So imagine I have about 40 of this identical triangle, and I just put one by the wall, and I just stack one after the other, stack them together to make a 3D shape. This was what happened. So from a 2D, I'm trying to sort of elongate the 2D. That's why I'm stacking them, and that gives us a new 3D shape, and that 3D shape is called a triangular prism. It's a prism made of identical triangles, so we call that triangular prism. And you understand that I was stacking them along this way, so going forward. So there's a path along which the stacking is done. This is the path along which I was stacking, or whichever way you look at it is the same. This is the path along which I was stacking the triangle. We call that particular line the length of the prism. So that is the length of the prism. Length is simply the path along which the triangles are stacked. We call the length of the prism. It's very important to identify the length, because that will lead us into another keyword I will explain later. Look at a pentagon. What happens when you stack pentagons, identical pentagons, the same way as we did the triangle? We're going to have a new 3D shape. And what name will you call that? It's a prism, but how will you call that? If that is called triangular prism because it's made of triangles, what will you call the one made of pentagon? Pentagonal prism, right? If you said that. And the stacking is done along this line. Any of these lines mean the same. That is the part along which the stacking is done. It's called the length. And that gives us another keyword we call the cross section. What is a cross section? Anytime that you slice a prism along the length, it reveals the original shape that is used to create the 3D. So the original shape that reveals itself when a slice is done along the length is called the cross section. The original shape, or the shape that is revealed anytime a slice is done along the length, is called a cross section. So here the cross section is a pentagon, the cross section is a triangle. So the formula for a volume of prism is giving us the area of the cross section, then you times it by the length. So all you need to do is to work out the area of the cross section and multiply it by the length. That's why it's really important to be able to identify the length and the cross section. Wrong identification leads to wrong calculation. Let's look at a simple question. We are supposed to work out the volume of these two prisms. Given that the formula is area of cross section times by length, we know that is the cross section. That's the cross section. We know these are the lengths. These two are the lengths. So if you want to work out the volume, just multiply the answer for the cross section by the length. So we go to A. What is the shape of the cross section? It's a triangle. We go to B. What is the shape of the cross section? It's a trapezium. What is the length of A? 15. What is the length of B? 12. So these are very important that you identify them first before you begin your calculation. Because if you don't understand cross-section and length, what are you calculating? And it's very important that you know how to calculate various 2D shapes. Trapezium, circle, every 2D shape, composite shapes, you need to know how to calculate them. So here, area of a triangle is base times height divided by 2. And remember, base and height must give you right angle all the time. So cross-section area is 12 cm squared when you work it out. Length is 15, so 12 times 15, 180 cm cube. Note, area is square, volume always cube. B, cross-section is a trapezium. Formula for trapezium, if you recall, A plus B, all times by the height, and divide the final answer by 2. A and B are your parallel lines. So that is A, that is B. Height is the vertical distance or perpendicular distance between A and B, so that is 5. And 12 is the length. So cross-section, when you work it out, 35 cm squared. Length, 12. 35 times 12, 420 cm cube. Simple as that. These are another prisms. If you look at A, L shape is the cross section. L shape is the cross section. And we stack them along this line. So that is the length. Cross section, length. Let's look at B. Think of it as a disc. A disc is circular. When you stack tens of discs upwards, you form a cylinder. The stacking is done upwards. So what do you see as a height? This time is the length. Terminologies are very important in volume. So even though this is the height of the cylinder, it is the length because the stacking is done what? Upwards. And each is a circle. So the cross section is a circle. So let's look at A. To work out A, let's put the cross section by the side. Okay, so I've put the cross section. I need to work out what is missing here. This line is 9, and 9 is equal to 5 plus something, because this gap is the same as the gap up here. So 5 plus 4, because 9 minus 5 gives you 4. So this gap is 4, therefore the top line should be 4. Now let's split the cross section into two distinct rectangles. First area is 32, second area is 15. So the total cross section area is now 47. 32 plus 15, 47. Now I know my cross section. What is my length? 10. 47 times 10, 470 cm cube. So I know the volume of A is 47 cm cube. Cross section is a circle. Circle is pi r squared. Radius is 6, so pi times 6 squared, 36 pi. Length is 16. 16 times 36 pi will give you 576 pi, which translates into 1,809.56 centimeter cube to 2 decimal places. So the volume of the cylinder is 1,809.56 centimeter cube. Now try and work these two yourself. Volume of these two prisms. Pause the video and work it out. Okay, let's check the answer. Cross section 12. 12 times 12 the length, 144 cm cube. Cross section of trapezium, area of cross section 32. Times it by the length 5, 160 cm cube. Hope you got it right. Now here we have the volume as 84, and we need to work out the length. So we need to work out the length of AB. Volume is area of cross section times the length. Put the numbers in place. Volume is 84. Area we don't know yet. Length we know it as what? 12. Put them back in. Formulate the equation. We are multiplying area by 12. So to reverse that, we divide both sides by 12. So the area actually equals 7 cm squared. Now, this is the area that we are working out, and it's 7 cm squared. We know the base. What height should give us an area of 7 cm squared? So that means the 7 is equal to 4 times a number AB that I don't know, divide by 2. Multiply both sides by 2, you have 14 equals 4 times AB. Divide both sides by 4. So AB is 3.5 cm. 3.5 cm. Similarly, on the other side, volume is 330. 55 is the cross section. Slot them into the formula. All you need is to work out L. And to work out L, you divide both sides by 5. And you have L to be 6 cm. Problem solving question. So we need to work out the volume of this weird prism. We do understand that the volume is simply the cross section times the length. This is the length, and this weird shape is the cross section. How do we work out that? Let's examine the cross section closely. So we pull it aside. Okay. Now, because it fits in 12 by 12 dimension, we can sort of make this into a square and divide this into 4 equal parts. So I'm going to put a square 12 by 12 around it and divide the cross section into 4 equal parts. So this is what I'm going to have. Now, I'm going to pull each quadrant or each quarters aside and rearrange them and see what sort of shape I'm going to have. Okay, so what I see here is a circle that fits inside a square. Right. Now let's examine something here. 1, 2, 3, 4. It's exactly what you see here. 1, 2, 3, 4. So if I manage to work out the area from this side, it will be the same as the area of the cross section. And those 4 sides outside the circles are simply the difference between the area of the square minus the area of the circle. So actually this cross section represents area of a square minus area of a circle. So a square is 12 times 12. Pi r squared is circle, so it's pi 6 squared. So cross section is 144 minus 36 pi. You can convert it into a decimal, but I prefer to leave it this way. I'm now going to multiply 144 minus 36 pi times it by the cross section of 20. And the calculator will work this out as 618.05 centimeter cube. 608.5 centimeter cube. So the volume of this prism is 608.05 centimeter cube. Okay, now let's look at this exam style question. We have a swimming pool with the dimensions given, and this swimming pool is empty, but we've been given some restrictions. The swimming pool is filled with water at a rate of 5 liters per second. That means that every second we can pour 5 liters of water into the swimming pool. At that rate, every second 5 liters of water. And Jeremy have 10 hours, and the question is, will 10 hours be enough to really fill this swimming pool? And also 1 meter cube is the same as 1,000 liters. So we start by first finding the volume of the swimming pool. To find volume, we need to find the cross section. This is the cross section. This is the cross section. So I divide the cross section into distinct shapes. First, 1 times 10 is 10 meters squared. Now that's a trapezium. Let's get the dimensions right. So the dimensions are 1 meter on this side, 3 meters, as you can see. But this side is 5 meters because 15 minus 10 gives me that. So the area of the trapezium using A plus B times by height divided by 2 also gives us 10 meters square. So total cross section is equal to 20 meters square. 20 meters square. Now, we are supposed to work out the volume. The length is 10. So volume now gives us 200 meter cube. 200 meter cube. Now, let us try to convert 200 meter cube into liters. If 1 meter cube is 1000 liters, 2 meter cube will be 2000, 3 meter cube 3000, and so on. So if it is 200, we multiply 200 by 1000, and 200 meter cube gives us 200,000 liters. 200 meter cube is 200,000 liters. That means that this swimming pool can take 200,000 liters. Now at this point, there are different ways you could work this out. You can decide to see how long will it take to fill the pool with 200 liters of water, and you compare the time with 10 hours. That's another way of doing that. So that's what I'm going to do. So I'm going to use the rate 5 liters per second. Every second I can pour in 5 liters. How many seconds will it take to pour 200,000 liters? You divide 200,000 by 5. So that means that it will take me 40,000 seconds to completely fill the pool. 40,000 seconds. So now let's convert 10 hours into seconds and compare if it is more or less than 40,000 seconds. And hours to minutes is times by 60. Minutes to second times by 60. So we're going to times 10 by 3,600. And 10 hours will equal 36,000. And since 36,000 is less than 4,000, we can say that we cannot fill the pool completely in 10 hours because we need 40,000, but the hours given is only up to 36,000 seconds. And therefore, 36,000 seconds is not enough to fill the pool. So the answer is no. Jeremy cannot fully fill the swimming pool in 10 hours. That brings us to the end of lesson 2. I hope you've enjoyed it, and please share with your friends, subscribe, and hit the notification button. In our next lesson 3, we'll be talking about volume of spheres and hemisphere, and we'll also talk about frustum, pyramid, and cones. So our next lesson, lesson 3, will be on cones, pyramids, and frustum, and the 4th lesson will be on sphere and hemisphere. Thank you very much for watching. Subscribe, share with your friends.